All right. So again, this is two positions for the current in elements of computer. Current is on is equals 1 and current is off is equals 0. In this case, we understand that only two digits that can be contained in the computer and can be memorized in the memory is 0 and 1. But number of these zeros and ones could be tremendous because the cell that we have, little cell, and this little cell can be either 1 or 0, is the same cell, named 1 bit. 1 bit. This 1 bit can tell us the logical situation. By the way, it could be yes and no, it could be on and off, it could be left and right, it could be dead or alive, it could be eligible or not eligible, and so on. 1 bit. Bit is abbreviation, folks. That's meaning binary digit. Binary digit. But also we have 1 byte. 1 byte is measurement unit for information in textual form, because in American Standard for coding, meaning alphanumeric information, ASCII code is American Standard Code for Informational Interchange. We have 8 bit per character. 8 bit per character. And character meaning from 1 to 0, 9, 8, 7, A, B, C, slash, dot, and so on. Whatever characters we have on a keyboard and whatever characters we can actually type for the information. What is this session? This session dedicated to programmable devices. The previous session, folks, we missed it, unfortunately, because I made it in Friday, but Friday nobody came, so I put recorded session in the recorded session collection, and that is continuation of that session. So 8 bit per character, but folks, 8 bit per character using the famous formula for number of variations, Q number of variations, Q, we will calculate how many variations here, 2 in the power of 8. Power of 8, or 8 power, 2 and 8 power. We need to multiply 2 by 2 by 2 by 2 8 times. So that will be 256. 256. So ASCII code, by the way, allows you to encode in binary system 256 different variations of alphanumeric information. So all in English, Spanish, Italian, German, and all languages that based on the Latin alphabet could be encoded and could be placed on the computer. The common problem that could be suggested to you in final exams. For example, the book of Bible contain 8 million characters. 8 million characters. Then it been digitized. Question: how many byte is a file size? How to approach this? We know that 8 bit per character is 1 byte per character, because 8 bit is 1 byte. 8 bit is 1 byte. Then 8 million characters, that will be 8 million bytes. So the answer is 8 megabyte. 8 megabyte. the size of the file. Why so? Because every byte is a character. Every byte is a character. Speaking about other languages, folks, there are many languages that are not based on Latin. For example, that is Chinese language because it's hieroglyphical like this, and Hebrew language, which is letters like this. Um, then Ethiopian, African languages like Swahili and Irbo, and Chinese, Cantonese, Mandarin, and in the planet Earth, it's about 60,000 different languages. Every language contains their alphabet. So what we can do in this case, they definitely cannot fit inside of the American Standard Code for information. But internet, actually, these people in the countries, they use these languages, they want to use their languages on internet. So computer must be tuned up for this situation for them. And people who designed internet, they choose different encoding. They call it Unicode, folks. Unicode. That is something that we didn't speak yet. Unicode. Instead of 8-bit per character, they made 16-bit per character. 16-bit per character. In this case, we need to understand the Q for Unicode will be 2 in the power of 16. 2 in the power of 16. 2 in the power of 16, folks, I don't remember exactly, but this is approximately 65,532, something like this. It's not exactly, but it's more than 65,000. Definitely, so we can place all languages in this code. But how this code looks like? If ASCII code character looks like this, let's say A will be 1001 1001, something like this. In Unicode, it will be looking like 2 bytes. So that will be 00000001 1001 something like this. So that will be A in Unicode, and that is A in ASCII code. In Unicode, we have much more space for this. So definitely for Unicode, the file for the Bible will take not 8 megabyte, but in Unicode, that will be 16 megabyte. 16 megabyte. Folks, prefixes, mega, giga, and so on. I'll put it here. So we have kilo. Kilo is 10 in the power of 3, meaning this is 1,000. Mega, this is 10 in the power of 6. This is million. Giga, this is 10 in the power of 9. This is billion. And tera is 10 in the power of 12. That is trillion. Next will be peta. I don't know about more. Peta is 10 in the power of 15. And that is, if this is a trillion, that is quadrillion. So folks, then we can measure the size of information in these measurement units. Speaking about this, I covered that computer can represent textual data with binary code. But now I would like to touch what we already discovered, that we can represent any digit and quantity in binary code 2. For example, I will take quantity 101101, and that is in binary. Uh, Principle of the record of the binary the same as a record for decimal. If I say 1575, so that will be number of positions. This is decimal, definitely decimal. Position 0, position 1, position 2, position 3. And these positions associated, this with the singles, this with the tens, this one with hundreds, and this is with thousands. 1000 is 10 in the power of 3, 100 is 10 in the power of 2, 10 is 10 in the power of 1, and 1 is 10 in the power of 0. So what I can do here, 1 multiplied by 10 in the power of 3 plus 5 times 10 in the power of 2 plus 7 times 10 in the power of 1 plus 5 times 10 in the power of 0. That is how can we actually represent this quantity with a number of money bills. So that is 1,000 bill, 500 bills, 710 bills, and 5 singles. Now, what about this? This quantity 101101 binary also has a positions. That will be position 0, 1, 2, 3, 4, and 5. So when we create the polynomial with these numbers, that will be 1 times 2 in the power of 5 plus 0 times 2 in the power of 4. You can surprise why this is a 2, because in decimal system we have 10 digits. 10 digits, folks. 10 digits is from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Totally 10. So I put 10 here. Then here is 0, 1, so that will be 2. Plus 1 times 2 in the power of 3 plus 1 times 2 in the power of 2 plus 0. You can surprise why this is 0 and this is 0, because these multipliers are zeros. Multiply by 2 in the power of 1 plus 1 by 2 in the power of 0. Easy to calculate this, and then we will convert it into decimal. 2 in the power of 5, folks. 2 by 2 by 2 by 2 by 2. That will be 2 by 2, 4, by 2, 8, by 2, 16, and by 2, 32. So that will be 32 in decimal. Then 0 multiplied by nothing will be 0. 1 by times 2 in the power of 3, that is 8. 2 in the power of 3 is 8. Here is 2 in the power of 2, this is 4. Then this one will be the 0, and that will be 1, because 2 in the power of 0 is 1. So now we can will be able to calculate. 32 plus 8 will be 40, so that will be 45. 45 in decimal. So folks, that actually proves that in this case we can use binary code to represent any quantity. The rules for calculations, folks, is the following. 9 plus 1 is 1, 0. 1 plus 1 in binary is also 1, 0. That is bin, that is that. This rule could be the highest digit plus 1 will be 1, 0. Let's get a couple of arithmetical actions. Uh, Before I do this, I would like to tell you the small digits, this, how much it will be in binary. So 0 is 0, 1 is 1, 2 is 1, 0, 3 is 1, 1, 4 is 1, 0, 0, 5, folks, is 1, 0, 1, 6 is 1, 1, 0, 7 is 1, 1, 1, 8 will be 1, 0, 0, 0, and 9 will be 1, 0, 0, 1. You will be able to remember that. And now, what I would like to do, folks, I would like to add number 3 uh, to this quantity. 3 is 1, 1. By the way, why 3 is 1, 1? Let's go. 1, 1, 0, 1. That will be 1 by 2 in the power of 1 plus 1 by 2 in the power of 0, which is 3. So I will take 1, 0, 1, 1, 0, 1, which is 45, plus 1, 1, and then we can calculate. 1 plus 1, 0 writing, 1 carrying. 1 carrying plus 1, 0 writing, 1 carrying. 1 plus 1, 0 writing, 1 carrying. 1 plus 1, 0 writing, 1 carrying. 1 plus 0 will be 1, and 1 falling down. So we have like this. And I would like to convert this one to decimal. 1, 1, 0, 0, 0, 0. Binary. How much it will be? Positions 0, 1, 2, 3, 4, 5. So that will be 2 in the power of 5 plus 1 by 2 in the power of 4. All other digits are zeros, you can see here. So 2 in the power of 5 is 32. 2 in the power of 4 is 16. So that will be 52, 58. So that will be, that will be 48. 48. 48 decimal. So take a look, folks. I made calculations in binary format, and I took 3 and add to 101101, which is 45. Which is 45. So, and then I got 48 decimal, which is correct. So that meaning my calculations independable on what system I use, binary or decimal. That meaning computer can use calculations, any calculations in binary system, and that will be correct result. That meaning computer can do 3 very important functions. First, it can represent human textual information. It can represent quantities in binary code, and it can make calculations. And also, folks, it can make decisions. We spoke about logical operations, meaning we can ask questions. Is that true or is that false? Right? And computer can give you answer. If it's 1, it is true, and it's 0, it is false. Now, how that happened? What computer must have inside to make this all operations? Let me show you the structure. Let me show you the structure. All right. The structure of the computer. First of all, when I use white paper like this one, and you can see it, I can memorize data on this paper. I can say the A is equal 3, for example, and you will be understandable that this is nobody will wipe it off until the paper is destroyed. But computer doesn't have any paper. Computer has electronic devices. So what we need to do, we need to understand that computer must have electronic table that substitute the white paper for us. This is electronic table. Electronic table, folks, must have cells. So this is a cells. Now cells definitely must be binary. So sorry, all of this table has cells with bits and bytes. How many bits in a cell? I'll tell you that contemporary computer that I use right now with you, this computer is 64 bit per cell. So if I would like to place the word inside of the cell with alphanumeric, so that will be 64 bit. How many byte? 8 byte. So that will be 8 characters or 8 byte. Now, every cell contains ability to record information and to give information away, meaning I can read and I can write like a paper. So when I read, information will not be wiped off from the cell, but when I write, then cell will be substituted with the new information. How do I know which cell I can use? Cells are supplied with address. Address is number. Number could be like this. For example, 00011. That will be third cell, you can see. Zeros before mean nothing. But 11, I told you that this is third cell from the beginning. And then you can see it, number 3. How many cells in a memory? Folks, billions. Billions. Contemporary computer usually utilized gigabyte of the memory. My new computer that I bought recently from the Dell, I prefer Dell company because they are pretty inexpensive and reliable, and they have pretty good customer support. So that is 64 GB, meaning 64 gigabyte, 64 billion bytes. All right, but don't forget that this is electronic device. So memory also could be used randomly. Randomly meaning processor, which actually device that use memory in the computer. We call it microprocessor, MP. It's a heart of the computer, actually the device that can make operations with memory, can take information from memory, can record information to memory, but it can do it in a random, into the random manner. What means random? So I can use cell number 3, then I can use cell number 1000, then cell number 1, cell number 10,000, and so on. Nobody limit me or microprocessor to use any cell. So we call it random access memory, or RAM. Random access memory. Folks, a random access memory is element of the computer that can be substituted. For example, I had computer with 16 gigabyte of RAM, but it was not enough for my purpose for recording videos for you. And I bought additionally 16 gigabyte and installed it there. So memory could be upgraded, as well as microprocessor. Folks, microprocessor has bidirectional connection to the memory. What's mean bidirectional? It can read from the memory and can put information into memory. So read meaning getting information from memory, and write is information must be placed in a certain cell. So we already said that memory used for data. And since memory is powered, computer use power for the electrical current. Since memory is powered, that memory will save information. When computer will lose power, definitely memory will be zeroed. That is feature of computer memory. So we need to save our work. We need to save that on the devices that can actually be safe without power, and that is either flash drive or some kind of devices that uh, can be um, with information without power. So, sorry, microprocessor. Microprocessor is a very interesting device. It can do many operations, such as addition, multiplication, root, uh, logical operations, tons of operations, but microprocessor doesn't know what to do. It don't have any imagination of what to do to get results. So question, how computer getting results? How computer actually understand what to do? Because microprocessor can be controlled by the program. Program. Folks, program is set of instructions. That is set of instructions. Set of instructions. So to do something with data, microprocessor need to read cells where it is instructions for microprocessors is actually recorded. So let's imitate, let's create uh, such a program, right, which will do certain things. I would like to make a program to calculate a square plus b square and put it in C. So C is equal a square plus b square. In the algebraic language, I will say C is equal a square plus b square. But in the computer, I will say a square plus b square, and I'll put this arrow. This arrow mean and put it into C. All right. So the programming of this algebraic formula started with distribution of cells. Let me use cells, and I will use cell 0011 beginning from cell number 3. That will be information A. 0100. Folks, this bracket meaning content. So I just taking uh, any empty cells from the memory. I consider that computer is mine, so I can use any cell. So that will be B. All right, something for C, 0101, and this is cell address. This is not content, this is address. But content of this cell with address will be our variables. So how to understand this? Variable C will be placed in a cell with address 0101. Now I need a couple of empty cells. I will put cell 0110 for empty. Then I will put 0111 also empty. But I mentioned to use it. Okay? So then I need to say what operations I will use in my hypothetical microprocessor. Usually Intel microprocessor contain like 500 different operations, but I do not remember that operations, and we don't need to list all of them, and we cannot. So consider this is my design, computer of my design, and yours design. So I will use operations like this. So operations, I will say operation in this frame. Operation 010, that is code of operation. That will be add or just plus. 011 will be subtract or minus. Then 100 will be read. 101 will be write. Where? To memory. Okay? Then operation 001 will be display. Display meaning send to monitor. Send it to monitor. And operation 111 will be print. Okay? So very poor system of operations, but I can already run the program. So let me do program like a table. And that will be table with 3 columns. That will be code of operations, and that will be address. That I'll put COP, code of operations, and this is address 1 and address 2. So what I'm going to do, folks, I'm going to write the program that will calculate this. Very first thing, I forgot a couple of information that I need. Let me use here, that will be continuation. 1000 cell. I will put information in textual form. Input type A. 1001, that will be type B, meaning the value for A and B. So the first, I forgot one operation, that will be stop. I'll put it 000, stop. Okay, starting. First, I would like to send information for user, that user must type the value of A. And I will put operation code display 001. And what to display? Display this message, right? And the cell will be 1000. Cell 1000. Meaning, I cannot tell computer input type A because computer can understand only binary content. But I can place in binary form the information input type A and place it in a cell number 1000 in ASCII code. Definitely that is ASCII code. Okay, the address 2 is not in use in this command, is just empty. Then when user input the value of A, I need to write it in the cell. Right, code operation 101, folks. 101. You can see it here. 101 is right. Which cell I will use? Definitely cell for A. Take a look. The cell is 0011. So I will put here 0011. And then, folks, that is that command, meaning I'll put commentary here. That is write A value. Then again, I need to display next text type B value. B value. And display is display is 001, 001. But now I need to display this information, 1001 cell, 1001 cell. And again, address for the third column will be not in use. So next I need to write down the B value, and the writing will be 101, and I need to put it in B, and B is 0100, and that is B cell. And here I put write B value. Where this value came from? From the user, because when user saw the message that computer sent to the screen, it or he will type the value. Now I need to calculate a square. Let's go and calculate a square. I will read A. Read A, where the read? Read 100, meaning 100. 100, and A, cell A is 0011. Then I need to multiply by itself to calculate a square. Multiplication. What is the code of multiplication? I don't have code for multiplication. Let's input code for multiplication. 110. That will be multiply. 110. It's multiply by itself. 0011. You can see read A multiply by A. So now microprocessor contain a square. And I would like to put some in some empty cell. And I'll put write. Write is 101. And I will use the first empty cell, which is 0110. And here I'll put a square. A square is calculated. Now, continuing. Let me read B. Read, folks, is 100. and b in this case is 0, 1, 0, 0. Multiply by itself. 1, 1, 0 is multiplication by the same cell content. So that will be b square calculated. And now I need to write it down to another empty cell. Right is 101 to empty cell 0111. Now in this cell will be b square. So I calculated a square plus b square, a square and b square. So now what I need to do, I need to add them. Add. So I will take addition. Addition is 010, and I will use cell 0110 and cell 0111. Two cells will be calculated, the sum of them, and eventually I will put this to C. Right is 101, 101, to C, and C is 0101 cell. And I'll put here C is calculated. Now, folks, I can print C. I can print C, so user will see, or display C. I can prefer whatever. So let's print it or display. I mean, we work with display, so let's display C. Display C, the code is 001, and what to display? 0101, that is C is displayed. C is displayed. And the last cell, I mean, I don't have space here, but I put it here. I put it here, so that will be the last cell in the program. The last cell in the program will be stop. Stop is 000 operation, meaning no any values in address. So that is a program, folks. That is a program that we created to calculate this formula. What I would like to tell about it. This is very primitive code, but computer actually works on these codes, and microprocessor, when it reads the first cell of this code, it will start using next and next and next and next and next. But what if I put certain conditions? So I will use conditions like this. If a greater than 0, or if a is positive, then I will use this formula. But if a is negative, I will use a square minus b square. Right? In this case, I need to create two of these sections of programming. One for the formula a square plus b square, and another one a square minus b square. And I need to create a conditional operation, folks. Conditional operation. What is conditional operation? Let me take this piece of paper, and then I would like to put this piece of paper again and explain what is conditional operation. The idea of conditional operation is to change the direction of calculations according to the logical function. According to the logical function. Let's put conditional operation, conditional. conditional operation. For example, operation if. So if, again, this is the human code of operation if. But in the computer, we have here operations for the computer. But let's go and make uh, 1, 2, 3, 4, 5, 6, 7, 8. 8. I will make code operation 1000, like 1000. 1000. If something greater than 0. Then I will make code operation 1001 if something is greater or equal than 0. Next operation will be 1010. That is digital code of operation not greater than 0. And that will be 1011. That will be not greater or equal 0. So folks, this is functions of operation if. How that looks in algorithmic idea. But I didn't tell you that this program could be represented in the graphical format. Let me explain what is a graphic format. Folks, before we actually do the coding, we need to create algorithm. Algorithm is description of the actions in the graphical form. Let me give you a sample. Consider that somebody is sitting in the room. So this is somebody. The view from the ceiling. And this somebody, let's say me, need to measure how many steps will be from one wall to another wall. How many steps? To measure how many steps, we need to start walking and counting steps. Step number 1, 2, 3, 4. But in every step, we need to ask ourselves, is the wall which was opposite to us already in front of us? So let's write algorithm for that. First, I need to create variable, let's say variable n, which will be number of steps. And instead of put digital codes, I'll put verbal codes, because translators from the human language to computer already existed. So we can use the algorithmic writing. Let's go with the first model. The first model will be like this. Take 0 and send to n. Folks, what that meaning? I don't know which content in the cell which will accommodate n variable, but I need to put 0 in this cell, meaning we'll start from the 0 steps, and n is number of steps. Then I need to make a step. Make step. So I will be right here. After I made step, what I need to do? I need to take n, which is counter, add 1, and write to the same cell. I will write it down to n. N is where n cell actually existing. So they're the same as we did in the program. I took the cell where n is, add 1, and record there. And then something magic, folks. I need to ask myself or computer, and that operation will be depicted as a rhomboid, is the wall here? Meaning I'm already in front of the wall, and I put question. This is operation if, actually. So I can say presence of the wall here is true, and that question could be started like this: is that true that wall is here? So if that's true, that will be 1. If that is false, that will be 0. So I can say this sentence is sentence X, right? And instead of this, I can create this module: is X equals 0. But for understanding, I'll put it in the form you can see here. Is the wall here? And then the answer no, meaning 0. And I will go to make another step. And if yes, I will go to print n and stop. Now, folks, you can see we have 2 exits in the model. The order of the modules could be changed. So meaning the module that detect true and false is conditional module. And this module can readdress a program to another cyclical make step, or to go to exit, which is print n and stop. In this case, folks, I believe I finished with this explanation, and we'll continue in the next week. I will put this video quickly, and one more video will be placed about algorithms, and the next test will be placed in a test area tonight or tomorrow morning. Any questions, guys? No questions? All right. If there is no questions, folks, let me express my appreciation for you for coming to the session, and I hope this recording will be placed tomorrow on the recording area of the Blackboard. Again, thank you for coming, and good luck.